Hey guys, it's Yared of Jump Zero. Welcome back to Programming in Objective-C. In the previous lesson, you remember, I left you with a big unknown. How to use introspection to verify which class an object is instance of, and how to check if an object can respond to a specific method. Well, before starting with introspection though, I need to introduce a new Objective-C construct, the selector. A selector is a way to refer to a method with its name. It's a really special construct and it's at the base of the Objective-C messaging system. Selectors are assigned to a type named cell, and they can be vectorized with the directive @selector that takes the method name as parameter. From the lesson about messages, you remember that a method name is split over the number of its arguments. So for example, fire at position with power. This is an example of a selector definition. As you can see, in this definition we haven't written any reference to objects or classes, we are only referring to the method with its name. A selector refers to the method name and not to its implementation. So if two methods have the same prototype, they share the same selector. Alright, now that we have defined the selector, how can we use it? Every object derived by NSObject have a method called performSelector that obviously takes a selector as argument. So to call a method, we can use standard message. So for example, spaceship fly. Or we can define a selector like cell mySelector equal to @selector fly. And then use the performSelector on the object. So in this case, spaceship performSelector mySelector. But with this simple example, you can't really understand the flexibility gained with this construct. Let's see another example. Let's say that the random receiver C function returns a random object that can be an instance of various classes. And then random selector returns a selector chosen from a set of possible methods. So with performSelector, in this case, you are defining which message to send and who is the receiver at runtime. This is a totally dynamic definition, and as you can imagine, it can be really powerful because you can define a big part of your application at execution time. Okay, now that you know what a selector is, we can get deeper into introspection. As I told you, introspection is the capability of an object to get details about itself at runtime, like verifying the class the object is an instance of and checking that an instance can respond to a specific message. All features that are needed to be sure you are working the right way with dynamic typing and binding. So let's take the example from the previous lesson and use introspection methods to add some tests. If you remember, the method fire will crash if the target object can't respond to the message coordinate. So, first we check if the object can respond to coordinate message, sending the method response to selector on the object itself. And so, we are sure that only the right object will receive the coordinate message. Now, let's add some complexity to this code. Take a look at this hierarchy. And let's say that spaceship, asteroid and lunar base are all subclasses of GameObject. Now let's modify the fire method to accept only objects inherited from the GameObject class. We can obtain this result using the function isKindOfClass. Take a look at the parameter we pass to this function. We obtain a reference to the class that we need, with this awkward call, the method class on the class GameObject. Well, with this code you simply get a pointer to the GameObject class. And with the method isKindOfClass, you are checking whether the object is a GameObject or a descendant of GameObject. And if you want to verify whether an object is member of a specific class, for example asteroid, you can instead send the message isMemberOfClass. And now isMemberOfClass will return yes only if the receiver is instance of asteroid. And so with these methods, you are able to check your code at runtime. So let's modify the previous example using the method isMemberOf to check that the target is of type spaceship. Now we can compile without errors, because only object instance of spaceship will be used on the method destroyTarget. And we know that this class responds to message coordinates. Okay, this is it for this lesson. Next time we'll take a look at the delegate pattern and we'll understand how objects in Objective-C communicate with each other. Bye, and thanks for watching.